All right, let's talk about logarithms. So we need to start by remembering what a logarithm is, right? If y is a logarithmic function, log base b of x, logarithms are just the inverses of exponential functions. So we could convert this logarithmic form to exponential form. These mean the same exact thing. Okay, one's logarithmic form, one's exponential form. They're the same thing. Logarithm is just the inverse of the exponential function. The base of the logarithm is the base of the exponential function. We're going to use this. Okay, so let's get into example 2. Find the derivative of log base b of x. So again, just like in the first video, we don't know this yet, but we can find it. This one, you really can find it on your own. You don't need any Calc 3 for this one. And you have two choices. What do you like more? Implicit differentiation or derivatives of inverse functions? From my experience talking with you guys, you like implicit differentiation. You hate implicit differentiation less. So we're going to use that method, but you could also use derivatives of inverse functions because we know the derivative of the inverse function. So since these are the same things, then to take the derivative of the left, that's exactly the same as taking the derivative of the right. So let's take the derivative of the thing on the right. Implicit differentiation. Well, we know the left-hand side. That was the first video. The derivative of an exponential function is itself times the natural log of the base. But remember implicit differentiation, we're taking the derivative of this function with respect to x, but our variable y depends on x. Y is not a constant and y is certainly not x. Y and x are different. We also have to multiply by dy dx. Implicit differentiation, 3.7. And now we multiply that by the derivative of the right-hand side, which is really nice. And we're almost done. We're looking for the derivative of y with respect to x. So all we have to do is just divide this stuff over. I don't even feel like writing it. And we get dy dx equals 1 over b to the y times ln b. And you might say, sweet, we're done. But it gets even better. And I don't even mean that sarcastically and like, hey, it's getting better. I mean, actually, you're going to be happy. Because what's b to the y? B to the y is the same exact thing as x. That's what the equal sign means. B to the y equals x. So let's make our formula a little nicer. The derivative of y, which is log base b of x, is equal to 1 over b to the y, which we said was x, times the natural log of the base. So it's very similar kind of logic as what we found in the other ones, right? Taking the derivative of an exponential function means we have to multiply by the natural log of the base. Taking the derivative of a logarithm is actually just the reciprocal function. And then again, we have a logarithm of the base, specifically the natural log of the base. All right. So let's go back in our notes to the very beginning. Sorry, not the very, very beginning. The third page, and fill in another derivative. We said, and we showed that the derivative of a logarithm, any logarithm, is the reciprocal function 1 over x, but there's also a natural log of b floating around. So I said this third one was just a special case of the first. Well, let's just get into it right now. Let's look at the special case of logarithms. Just like before, something really nice happens if we're looking at the natural log. Because it's still just 1 over x times the natural log of e. And just like before, the natural log of e is 1. So these bottom two are really, really nice. Very simple, straightforward formulas. The top ones are also not as bad as they look. They're just multiplied by a constant or divided by a constant. Makes it a little less fun to work with, but not too bad. Okay, so use those formulas for this section. And that's pretty much... No, I'm not going to lie to you. That's not pretty much it. Let's do example 3. Find the derivative of the following. Part A. F of x equals the natural log of x cubed plus 3x minus 4. And of course here, right, like, we're going to have to use the chain rule. Chain rule's everywhere. So if you'd like, you could say y is just the natural log of u, where u is that inside, x cubed plus 3x minus 4. The natural log of u is just the natural log of x cubed plus 3x minus 4. And we could use the chain rule explicitly. If you're really comfortable with the chain rule, you don't have to do this step, but it can be very useful. dy du, du dx, the derivative of y with respect to u, we had that formula. The derivative of a logarithm is just the reciprocal, 1 over u, times the natural log of u, times the natural log of e, the natural log of the base is just 1 in this case. If we're a different log, like log base 2, then we'd have to multiply by the natural log of 2 in the denominator. Times the derivative of u with respect to x. Make sure to include parentheses here. Our rule says 3x squared plus 3 minus 0. All that's left is replace u. So we get 3x squared plus 3 in the top, and the denominator is u, which we said was x cubed plus 3x minus 4. And I would take this as an answer most of the time, but usually when we deal with rational functions, when we have fractions, it's best to factor just to make sure whether we can cancel or not. I don't think the bottom factors. It actually might factor, but I'm not having you guys factor trinomial or third degree polynomials. It's not something that I personally value as a skill in this class. All right, so there we go. That's how we do it. Part B. What about log base b? No, we'll save that. We'll save that for the part C. How about the natural log of x squared times the sine of x over 2x plus 1? And you might say, whoa, Jason, this is going to be a nightmare. We're going to have to take the derivative of the natural log and multiply by the derivative of the inside, and the derivative of the inside is going to use the quotient rule, and the part of the quotient rule is going to use the product rule, and we also have the chain rule again. What are you doing to us, Jason? Slow down. I can barely keep my head above water. You might be saying that. You might be thinking it. Don't worry. Also, there's a y equals here. Remember what you know about logarithms. Just like if I asked you to take the derivative of this, I would have you rewrite it first as x to the negative first power. Well, let's rewrite this one too, using properties of logarithms. Let's simplify first. If I have a logarithm of a product or a quotient, we can break that up into individual logarithms. This is the natural log of x squared plus the natural log of sine of x minus the natural log of the denominator. When you have a fraction, you can just add everything that's multiplied and subtract everything that's on the bottom. Properties of logarithms. And in fact, we can even do more. Remember that exponents inside of a logarithm, if you just have a logarithm of an exponential function or a monomial, that exponent comes out in front. There's no nice property with sine. That'll be a little annoying, but not too bad actually. And then again, be very careful here. We can't split this last one up. Addition messes up a lot of things. Addition messes up some fractions. Addition messes up square roots. Addition messes up logarithms. Addition messes up any function that is not linear. Okay. So, yeah, this is where we're at. So now this is not easy, but it is much easier to take the derivative of than what we started with. Now let's get to it. Derivative of the first one. Well, the 2 comes out in front, constant multiple rule, times the derivative of the natural log of x, which is 1 over x. And remember that we don't have to use a product rule here because product rule is only for a function times a function, but this is a constant times a function of x. Next one, we're going to use the chain rule. The derivative of natural log is 1 over the inside times the derivative of the inside. The derivative of natural log is the reciprocal. The reciprocal of sine x is 1 over sine x. And we have to use the chain rule, so we multiply by the derivative of the inside, cosine of x. Similarly, derivative of natural log is reciprocal. And again, we have to use the chain rule. The derivative of that inside function is 2. And now it's just housekeeping. Now it's just cleaning things up, but we're done with the calculus. This first one is 2 over x. The second one is cotangent. Cosine over sine. And this last one is 2 over 2x plus 1. I really don't think it's worth your time trying to combine these fractions. So unless there's a good reason to combine the fractions, I would leave your answer like this. Again, it would probably look a little nicer if you just combined these ones and left cotangent by itself, but I'll try to specify what I want. I will always try to specify what I want in terms of combining fractions, just like with the quotient rule. All right, let's do the last problem here. Part C, last one in this video. Y equals log base 2 of 3x plus 5 cubed. So again, you have options in this one. You can take the derivative immediately, or you can simplify first. Simplifying first is usually a good idea. Try to always look. Try to simplify first for any logarithm. Be on the lookout. It'll make your life a lot easier. So again, let's rewrite this. The 3 comes down, and we get 3 times log base 2 of 3x plus 5. And that's going to make that derivative of that inside function much easier. If you don't simplify first, I highly recommend putting brackets like this to really show the order on which you have to use the chain rule. Because it kind of looks like the cubed is the outside function, but this is what we really have. And this shows that the logarithm is the outside function. All right, let's take the derivative. Again, we have a number times a function. So we can use the constant multiple rule to get a 3 times the derivative of a logarithm. Now, natural log is just the reciprocal. Other logarithms are also the reciprocal, but they also have a natural log of the base in the front, right? The derivative of the natural log of something is its reciprocal, 1 over that something, in this formula that something is x, also times the natural log of the base. Watch out for that here. So it's the reciprocal of the inside times the natural log of the base. We still have to use the chain rule because we have a function on the inside. The derivative of that inside function is 3. And now all that's left is 3 times 3 is 9. We get 9 over 3x plus 5 times the natural log of 2. I don't think there's really anything else that is worth doing to this. I think that's fully simplified. Leave it factored. Anytime we have fractions, factoring is usually nice. And then there's no cancellation or anything. It's fully factored. That's it. All right. that's this video. We're going to do some more complicated examples in the next video for messier stuff. And we have also more examples in 3.9.5 and then 3.9.4, that fourth video. That's where the fun stuff happens. It really is quite cool. I hope you enjoy it. Good luck on the homework and let me know if you have questions.